Welcome to True Projects. In this video, we are going to explain about a project titled Prediction of Chronic Kidney Disease using the machine learning techniques. Currently, engineers and medical researchers are collaborating to create the machine learning algorithm capable of early detection of chronic kidney disease. The complexity and vastness of healthcare data present a significant challenge for analysis. However, data mining technology can be harnessed to transform this data into a suitable format for machine learning algorithm. By considering the factors like estimated filtration rate, age, diet, medical history, and many more, the severity of kidney disease can be assessed. Nevertheless, more accurate information is needed to make well informed clinical decisions about diagnosis, treatment, and referrals. The primary goal of this model is to develop and validate the predictive models tailored specifically for chronic kidney disease detection. Early detection of chronic kidney disease is challenging as a symptom are often not evident. The main goal of this study is to create and validate a specialized predictive model for chronic kidney disease. Machine learning algorithms are commonly used in the medical field for disease prediction and classification. However, medical records can be distorted or incomplete. To address this chronic kidney disease, dataset from the UCI Machine Learning Repository was utilized. Containing the relevant features for analysis, the bagging ensemble method was applied to improve the model's performance. Machine learning classifiers were trained using the clusters from the chronic kidney disease dataset. The researchers focus on implementing and comparing the various supervised algorithms to find the best combination that offered the high accuracy and detection rates. Algorithms like AdaBoost, XGBoost, gradient boosting, KNN, voting classifier, logistic regression, random forest, SVM, decision tree, and bagging classifier were employed along with the different feature selection methods considering metrics such as accuracy, precision, and recall. These are the basic requirements that are needed to build this project. Software requirements are Python IDE with version of 3.7, Anaconda with version of 3.7, or Jupyter or Google Colab. Hardware requirements: operating system as Windows or Linux, processor of minimum Intel i3, RAM of minimum 4 GB, hard disk of minimum 250 GB. To know the flow of the project, we write a detailed number of steps. The first step is importing libraries. In this module, the necessary Python libraries are imported that are NumPy, Pandas, sklearn are imported for data manipulation and machine learning algorithms. Additionally, Seaborn and Matplotlib are imported for data visualization and some additional libraries that are used in this project. And the second one is exploring the dataset. In this step, the dataset containing information that is related to the chronic kidney disease is loaded and explored. The dataset includes various features such as age, GFR, diet, medical conditions, and many more. Exploratory data analysis techniques are applied to gain insight into the dataset and understand the distribution of features and check for any missing values or anomalies. And the third one is data pre-processing. It is a crucial step to clean and prepare the dataset for model training. It involves handling the missing value, encoding the categorical variable, and scaling the numerical features to ensure all the data in a consistent format suitable for machine learning algorithms. And the fourth one is visualization using the Seaborn and Matplotlib. In this step is performed using the Seaborn and Matplotlib libraries to create the various plots and graphs. Visualization helps to better understand the relationship between the different features and their impact on the chronic kidney disease. And the fifth one is split the training and testing data. Before building the model, the dataset is split into the two sets, the training set and the testing set. The training set is used to train the machine learning model, while the testing set is used to evaluate the model's performance and assess its ability to generalize the unseen data. And the sixth one is building the model. In this model, Multiple machine learning algorithms are constructed and implemented to predict the chronic kidney disease. And the first one is logistic regression. It's a binary classification algorithm that commonly used for predicting the probability of binary outcome, and in this case, the presence or absence of chronic kidney disease. It estimates the relationship between the dependent variable and one or more independent variable that are features of fitting a logistic function. And the second one is decision tree. It is a non-linear supervised learning algorithm used for both classification and regression tasks. It works by recursively splitting the data into subsets based on the features, with each split being determined by selecting the best feature to split the data and maximize the information. Decision tree provides a visual representation of decisions and are easy to interpret. And the third one is SVM. It is a powerful classification algorithm that aims to find the best hyperplane that separates the data into different classes with maximum margin. It is particularly useful when dealing with high dimensional data and handle both the linear and non-linear classification tasks through the use of kernel tree, making it versatile for various data sets. And the fourth one is bagging classifier. Is an ensemble method that combines the multiple model to make the prediction. And bagging classifier, multiple base classifiers are trained on the different subset of the training data. The final prediction is obtained by aggregating the prediction of individual models, typically through the majority ODing. And the fifth one is AdaBoost, is an ensemble learning algorithm that builds multiple weak learners sequentially. Each weak learner focuses on the misclassified instant from the previous learner, making it adaptive. The predictions of all weak learners are combined to form the final prediction, giving the more weight to more accurate learners. And the sixth one is voting classifier. It is another ensemble technique that combines the multiple models by voting on their prediction. It can be of hard or soft voting. In hard voting, the majority class predicted by individual models, and soft voting, the class with the highest average probability is chosen. And KNN is a simple and initiative classification algorithm that assigns a new data point to the class of its nearest neighbor in the feature space. The value of K determines the number of neighbors used to make the prediction, and it is a lazy learning algorithm, meaning it doesn't require explicit training. And the eighth one is XGBoost, that is of extreme gradient boosting algorithm. It uses the decision tree as a base learner and focus on minimizing the loss function through the gradient descent optimization, which widely used in various machine learning competitions and real-world applications. And the ninth one is gradient boosting. Is an ensemble technique that builds the multiple weak learners sequentially, with each learner trying to correct the errors made by the previous one. And the 10th one is random forest. Here, random forest is another ensemble method that creates the multiple decision trees during the training and making the predictions. By aggregating the result of each tree, it reduces the risk of overfitting and provides the good generalization performance. Training the model. The models are trained on the training data using the corresponding machine learning algorithms. During this training process, the model learns patterns and relationship between the input features and the target variable. And the eighth one is user due the input. After the models are trained, the system is ready to receive the input from the user. The user provides the relevant information related to the chronic kidney disease such as age, GFR, and other relevant features. And the ninth one is the UN input is pre-processed for prediction. The user provided input is pre-processed to ensure it is in the same format as the data used for model training. Pre-processing includes handling the missing value and scaling the input features, and then the trained model is used for prediction. And this, the pre-processed input is then fed into the trained machine learning model. Each model predicts whether the input data indicate the presence or absence of chronic kidney disease. And the last one is final outcome is displayed. The prediction from all the models are collected and displayed to the user. The final outcome includes the predicted class and the relevant information This allows the user to gain insight into the health condition and take appropriate action if necessary. The execution of the project. To execute the project, first we need to open the code folder. This is the code folder consisting of different files within it. The dataset folder contains of the kidney disease dataset, and the static folder contains of the CSS, JS and different images within it. The templates folder contains of the HTML documents, contains of home, index, notebook, result, sign in and sign up, and also the static folder which contains of it CSS, images and JS files within it. And the app.py is a file contains the information related to the front-end logic. It includes the code written in Python that handles the server-side operation such as processing the user request, interacting with the database, and generating the dynamic content that to be rendered in the HTML templates. And notebook is an IPYNB file which contains the combination of code, graph, output all in one place. It allows the user to write and execute the code in individual cell, making it a popular choice for the data sign. And the signup.db is a file that appears to be the database file used to store the user information. And for execution of the project, first we executed and created an Flask framework as a front end. And for execution, first we need to copy this address path and open the Anaconda prompt. And our code folder is present in fdisk. That's why I'm writing this command and it's changed to the fdisk. Here we need to write of command cd space and paste this address of the folder and click on enter button. And we need to write another command of python space app.py. By this command, in the Anaconda prompt, the command will execute in the Python script and perform a runtime check for any syntax errors or logical issues and click on enter button. By running the app.py file, the Flask framework will host the application locally at the default address as this, and we need to copy this local link provided by the framework and paste it on the Chrome or any web browser. I prefer to use of Chrome, and paste it and click on enter button, and we get a screen like this. This is the home screen and we need to click on sign up button. The sign up button will initiate the registration process. Clicking on it will of taking the registration page as of like this, where we can provide the necessary details to create a new account. But my account is already registered, so I am clicking in the sign in page to give my username and the password as of admin and click on sign in button. And here we redirected to this page containing of notebook and sign out buttons. Notebook button will give the Jupyter notebook consisting of the full code within it, and the sign out button will signing out with this page. And here getting of different features within it, we need to fill all this one, and age is of 21 and blood pressure is 110 and specific gravity is 1.2 and the organic is 3 and the sugar is 3 and the red blood cells is 2 and the pus cell is 2 and the pus cell clumps is 0 and bacteria is 1 and blood glucose random is 132 and blood urea is 67 and serum creatinine is of 1.4 and sodium is 154 and the potassium is 3.6 and the hemoglobin is 14.6 and packed cell volume is 64 and the white blood cell count is of 877565 and the red blood cell count is of 6.3 and the hypertension is of 1 and the diabetes of 1 and the coronary artery disease is of 1 and hepatitis is 1, and pedoedema is 1, and anemia is 1. And this way we need to fill all these columns and click on submit button. By this we get an redirected page by that showing that you are safe, you do not have any disease. In this way we can predict the chronic kidney disease using the machine learning techniques. And for to give some other detail, press the back button and enter the new details within it. This is the comparison graph where x-axis represents the algorithms we used and the y-axis represents the each matrix number, where one bar represents the worm metric, where blue bar represents the accuracy, orange bar represents recall, green bar represents precision, and red bar represents FN score. And in conclusion, this project investigates the various machine learning algorithms and their performance in predicting the chronic kidney disease based on the analysis of the 14 attributes associated with chronic kidney disease patient. The accuracy of different algorithms such as decision trees, support vector mission, and many more was evaluated. The results indicate that the decision tree algorithms achieved an accuracy of 91%, while SVM-RISI achieved an accuracy of 96% and of many fold. The decision tree algorithm constructs a tree using the entire dataset and all its features, offering the advantage of faster prediction. The system can enable the doctor to initiate the early treatment of chronic kidney disease patient and diagnose a larger number of patients within a shorter time frame. However, the study has limitations due to the limited strength of the dataset, mainly due to its size and missing attribute values. To develop the machine learning model with an overall accuracy of 99% for the targeting chronic kidney disease, millions of records with no missing values would be required.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.